So today we're going to take a quick look at how we use state machines in Baita AI based on the theory presented in the last video, and how we can use it to significantly improve the accuracy of our models while reducing the amount of training data needed to reach that accuracy. So in this quick example, we're doing traditional video generation. There's a video generation server running, and so I'm going to say create a video for me, and then it's going to ask for title, subject, length of video, and then optionally an organization name. So the video's name is test.org, just for this demo, and that's what we're running this model under. The video's length is 10. The video's subject is mining. And then I forgot to add a prompt for the title, but the video's title is all about mining. And then now it says, okay, sending the data to the requested API interface. And this is just the default thing if you don't give it a prompt to say. That can easily be added in. And to verify that that actually got sent, we can go back to the generated videos. Today's February 9th, and it's created a video, and we can see this. I don't have screen capture for my whole screen, so I can download it, but it won't be picked up for the video. So it's 10 seconds long, 1080 by 920, and that's the thing. But how does it know how to do that? So what's the training data that we use to describe this? So if we go back to our application, our prompt training data is we got a set of prompts like traditional, all other AIs tend to follow this. Except you'll notice there's this response column, and most of it's empty. And you can put in responses. So treat this like just a good old-fashioned LLM-based prompt. User says this, say something like this. But we add this third column that's called triggers, which adds to another training data set or a configuration data set, however you want to look at it. And then you can do bulk uploads, bulk downloads, and then add individual prompts and outputs here. However, if we go to this this kind of triggers, this says, okay, how do you link prompts to activities that you take? Like, how do you make the AI do stuff? So for instance, ask for video length. You can configure to say, okay, give me the video length in seconds as a prompt. And if you notice, we do this, there's no user prompt that says when to call this. And we saw this, you can rewind the video and see it still asks for this. Well, that's where it uses the state machine. So the state machine, as the user's given prompts, the AI is keeping track of, like, when we load this data in, we build them on the fly. This says, okay, given a set of, requirements and messages, and what should be said to the user if I have nothing else to say? And then figure out what's the best way to do that. And then there's something called a self-optimizer that's still a little bit under development, not ready to show, that says, okay, how can we maximize some kind of objective that the user set, or that the system administrator set. And then once everything's done, then just go off and fire that. So there's no prompt I set for, okay, everything's done, go generate a video. It knows to do that. And when we can actually show that here is if we go to one of our sessions, we can say, these are just, the messages I sent and then what was sent back. It's keeping track of, this is the world model state. And it's saying, okay, I have training data that says when the user says generate a video and there's been no video subject, then we need to internally set a flag saying that there's this flag. Right now, you have to have training data for this. I'm working on having the AI figure out how to do this without the user specifying it. And then this is data that's collected. So it's saying, okay, this is the data that's going to be sent to the server. And these are the set of action states. So as the conversation's going, the AI is actually keeping track of live of what can it do and what is the next best action it can do at this given point in time. If there's a high priority action, then it tries to calculate what's the best high priority action that it can take proactively without being prompted to do so. And that's what you're seeing when it's responding to saying, okay, generate video. Well, some of these actions are, ask for the video subject, because we're going to need that to fill out the video subject line. So the reason why we do this is, one, you need a lot less training data. You just need to say, okay, when this data is missing, then this is what you prompt for, not saying, okay, going through a bunch of examples and where the user puts something in and then the AI has to then say, okay, I need to ask for this. You just let in the AI figure out like how to do that itself. And two, we're now given responsibility over the AI. So now the AI makes a decision about what it needs to do, and then it can keep track of that. And then, okay, you're keeping track of actions. Now you can optimize for that. Now you can do machine learning, saying, okay, the AI builds the machine learning, Beta AI generates a machine learning model behind the scenes. It says, what best actions can I take at a given point in time, given a set of world state configurations that lead to the maximum output. Now here in the video generation, that doesn't matter, but for instance, if in the example of a CRM I'm building, I'm going to show this next week, it's saying, okay, given a set of inputs, the action is a sales or marketing activity that generates a potential conversion lead or conversion or sale. And so the AI is trying to figure out, okay, when I'm talking to the user, which is in this case a sales rep, what are the actions I'm trying to give them to advise them that will then maximize the likelihood of getting a sale from whoever they're talking to. And further, again, going a little bit more into the theory is, so I'm working on this internal, something called an ILM, internal language model. So this is, I believe, for tic-tac-toe or checkers. Yeah, this is for tic-tac-toe, where I use the language model, where the tic-tac-toe model was generated through a conversation with the AI. And this is something I've never seen anybody do, where we say, okay, we have this model. I'm defining to the AI what tic-tac-toe is, and then asking it to play, and then having it figure out a strategy on the fly. So the training data is just me talking to it in a conversation. Now, unfortunately, I had to do this in, there's over 100 of these messages. This took like 2 weeks to do. It was painful. But ideally, like we're creating a language model that can compile this on the fly through like natural language of this. No user would have to ever deal with this nonsense. Saying, okay, the user's describing a problem to me that I've never seen before. I'm compiling an internal model of like, okay, what are we trying to accomplish? What are the things we are allowed to do or not allowed to do? What are we trying to optimize for? And then I'm going to create this, run some simulations, and then try to figure out like a plan of action that meets what the user wants. And this might be repeatable. So for instance, you describe tic-tac-toe to an AI once, and then it plays this over and over. And then I'm also identifying potential places, these kind of forks in the road, where if I make a decision, I don't know what the next best state to do. Again, going back to the non-deterministic finite state machines of the theoretical model of, world states. How do I figure out, like, build some model of giving some inputs and some actions, generate a machine learning model on the fly that can then improve my performance in choosing an action in this fork in the road in the future, and do this without anybody telling me to do so, without a programmer or system administrator telling me to do this. Just do this for free. And that is, what we're doing with Beta.